Good morning, everyone. Today we are covering Unit 1, Lesson 4, converting between polynomial expression forms. So we're going to first talk about what we've been doing for the past 3 lessons in terms of going between the two forms. So we've been going between factored form and standard form. And to go between these two forms, to go from factored form to standard form, we've been using this idea of expanding and simplifying. And when we expand and simplify, we're using that distributive law. And we've also looked at the idea of FOIL. So if we have a binomial times a binomial, we FOIL. To go from standard to factored form, we're just going to factor. And we've looked at different ways that we can factor. So we can common factor. We can factor by grouping. We can use SPF for simple or complex trinomials. And then the last one we covered yesterday was a difference of perfect squares. So let's first look at going from standard to factored form and the different factoring methods that we can use. So from standard to factored form. So we have x to the power of 3 minus 4x. So right away I see that there's x's in both my terms. So I'm going to common factor first. Always try to common factor first. So I'm going to pull an x out of both terms. So x to the power of 3 divided by x is going to be x squared. And 4x divided by x is just 4. Now I see in my brackets I have two terms. They're both perfect squares. And they are separated by a minus sign. So I'm going to factor by using a difference of my perfect squares. So I have to remember I've already common factored out x, so that needs to stay there. And then if I am doing a difference of squares, well, the square root of x squared is x, and the square root of 4 is 2. I'm going to have x plus 2, x minus 2. All done. Let's look at the next one. So the next one, again, I see I have an x in all of my terms. So I'm going to common factor out that x first. So let's common factor an x. So if I take an x out of each of my terms, what do I have left? Well, x to the power of 4 divided by x is x to the power of 3. And then x to the power of 3 divided by x is going to be x to the power of 2. Negative 3x squared, if I take an x out of there, I just have 3x left. And then if I have 3x divided by x, I'm just going to have 3 left. Okay, so now I look at what I have left in my brackets to see what kind of factoring I can continue to do. So some things that we could rule out. First of all, we've already common factored. If we want to use simpler complex, we need a trinomial, so we need only 3 terms. So here I have 4 terms. So when you see 4 terms, and maybe I'll make note of that up here, when you see 4 terms, we want to use a factor by grouping. So let's say 4 or more terms. With SPF, we have 3 terms. When we have a simpler complex trinomial, and a difference of perfect squares is 2 terms. So sometimes just looking at the number of terms we have will help us identify which type of factoring we should use. So I have 3 terms here. So I'm going to look at factor by grouping. So if I group together my first 2 terms, I could common factor something out of that group there. And if I look at factoring my last 2 terms, I could common factor something out of that group there. So we have y equals x. And oops. And then I'm just going to start a new bracket so I can common factor out of those groups I created. So x cubed minus x squared, I'm going to pull an x out, or an x squared out of that, right? Because I have x cubed, so I could pull x squared out of that, and I have x squared, which I could pull x squared out of. So if I did, x to the power of 3 divided by x to the power of 2 is going to be just x. And then minus, I have x squared divided by x squared, so that's just going to be 1. And then if we look at our second group that we can factor out of, so I have a minus 3x plus 3. So I can pull a minus 3 out of those. And I'm going to pull a minus 3 out, just because if there's a negative at the front, we like to pull that out in math. So if we pull a minus 3 out of negative 3x, we're going to have x left. If we pull a minus 3 out of a positive 3, we're going to have a minus 1 left. And now we follow those factor by grouping rules. We can see that we've created a common bracket piece that we can pull out, right? There's an x minus 1 in both of those pieces. So I'm going to pull out that x plus 1. We still have that x there. Then I'm going to bring out front my x minus 1. And all you're going to have left, if I pull an x minus 1 out of x squared times x minus 1, I have x squared left. And if I pull an x minus 1 out of this 3 times x minus 1, you're just going to have that 3 left. Okay, so I just want to make note here that after we common factor, we factored by grouping. All right, so that's going from standard to factored form. Let's now look at how we're going to go from factored to standard. All right, and we've seen this in previous notes. So I'll do the first one and then I'll pause and let you guys try that second one. So use the distributive property to multiply the leading coefficient on the first bracket, then expand the brackets, okay? So when we expand the brackets, we're going to use FOIL. So for the first one, I'm going to distribute this negative 2 inside my first bracket. So negative 2 times x is a negative 2x. Negative 2 times a positive 2 is a negative 4. And we'll multiply that times x minus 1. Now we will use this idea of FOIL to continue. So our first, outside, inside, last. So a negative 2x times x is a negative 2x squared. A negative 2x times a negative 1 is a positive 2x. Then a negative 4 times x is a negative 4x. And a negative 4 times a negative 1 is a positive 4. We will combine any like terms we have, which when we FOIL are always those ones in the middle. So we'll have a negative 2x squared, and then 2x minus 4x is a negative 2x plus 4. Okay, I'm just going to set up, I want to talk about this power of 2 here. So when we have a power of 2, that means you're going to take your bracket and you're going to multiply it by itself, however many times that exponent is. So we'd have x plus 3 times x plus 3 because it's a power of 2. So go ahead and pause the video and work out the distributive property to go from factored to standard form. Okay, so there's the solution for that second example. We distributed our 3x inside of our brackets, and we FOILed the idea of this here, the x plus 3 times x plus 3, and then we continue to expand and simplify the two brackets that we created, and finally we combined our like terms to get y equals 3x to the power of 4 plus 6x to the power of 3 minus 45x squared minus 108x. Okay, so that is your note for today.